Our sun, a blazing ball of fire. It's the heart of our solar system, the giver of life. This yellow dwarf star bathes us in warmth and light. Without it, Earth would be a frozen, lifeless rock. Every day we feel its energy. It's in the sunbeams that warm our skin. It's in the food we eat, grown with the sun's light. Even fossil fuels are stored sunlight from millions of years ago. The sun's gravity keeps Earth in orbit just the right distance away. This Goldilocks zone allows for liquid water, a key ingredient for life. Our sun dictates our seasons, weather patterns, and even our sleep cycles. It's a constant presence in our lives, even when hidden behind clouds. We often take the sun for granted, but its importance is undeniable. It's the ultimate power source, driving almost everything on our planet. From the smallest bacteria to the largest whales, all life on Earth owes its existence to the sun. Stars aren't just twinkling points of light, they're fiery furnaces with a story to tell. Each star, no matter how distant, is a blazing beacon of information, waiting to be deciphered by those who know how to read its signals. The night sky, with its myriad of stars, is like a vast library, each star a book filled with tales of creation, evolution, and eventual demise. And that story is written in their color. The hues of stars are not just for show, they are the cosmic language through which stars communicate their secrets. From the deep reds to the brilliant blues, each color tells us something unique about the star's life and characteristics. A star's color reveals its temperature, its age, and even its ultimate fate. The spectrum of colors we see is a direct result of the physical processes happening within the star. By studying these colors, astronomers can determine whether a star is in the prime of its life, nearing the end, or just beginning its journey. Just like heating metal changes its color, a star's temperature determines its hue. When metal is heated, it glows red, then orange, and eventually white as it gets hotter. Similarly, stars follow this pattern, with cooler stars appearing red and the hottest stars shining blue or even white. Cooler stars glow red, like embers in a dying fire. These stars, often called red dwarfs, are among the most common in the universe. Despite their abundance, they are not easily visible to the naked eye due to their lower brightness. Our sun, a comfortable yellow, is hotter than red stars but cooler than blazing blue giants. This yellow hue indicates a balanced temperature, making it ideal for supporting life on Earth. The sun's steady output of energy has allowed life to flourish on our planet for billions of years. These celestial behemoths burn with incredible intensity, their surfaces reaching tens of thousands of degrees. Blue giant stars are rare but incredibly powerful, their immense energy output lighting up the cosmos in a dazzling display. Blue stars are the rock stars of the cosmos. Their brilliant blue light is a testament to their high energy and short, explosive lives. They are the supernovae waiting to happen, the cosmic fireworks that will one day light up the universe in a final, spectacular burst. They live fast and die young, exhausting their fuel in a cosmic blink of an eye. Unlike our sun, which will burn steadily for billions of years, blue stars burn through their fuel quickly, leading to a dramatic and often violent end. Their blue light signifies immense energy output, a far cry from the gentle warmth of our sun. This intense energy is both a blessing and a curse, as it allows blue stars to shine brightly, but also leads to their rapid demise. Imagine our sun suddenly shifting from its familiar yellow to a brilliant blue. Such a change would have profound implications for life on Earth, altering everything from our climate to the very chemistry of our atmosphere. It's a captivating thought experiment, one that reveals the delicate balance of our solar system and the profound impact a star has on its planets. The color of a star is more than just a visual delight. It's a key to understanding the universe and our place within it. Let's imagine the impossible. What if overnight our sun transformed? No more gentle yellow, instead, a blazing blue disk dominates the sky. This isn't just a cosmetic change, it's a fundamental shift in the very nature of our star. A blue sun means a hotter sun, much hotter. Temperatures would soar on Earth, turning our once temperate planet into a furnace. Oceans would boil, glaciers would vanish, and deserts would expand, engulfing the land. This blue sun wouldn't be the life giver we know. It would be a force of destruction, unleashing intense ultraviolet radiation. The very air we breathe, the delicate ozone layer protecting us, would be in jeopardy. Life as we know it would face an existential threat. But within this scenario of chaos lies an opportunity. an opportunity to explore the limits of life's resilience and to imagine how life might adapt to such a drastic change. Section 4. Scorching heat and intense radiation, life on the edge. Imagine a world where the sun is no longer the familiar yellow orb we know, but a blazing blue giant. This is not a scene from a distant planet, but a hypothetical scenario right here on Earth. Imagine stepping outside under a blue sun. The sky, once a comforting blue, now radiates an intense, almost blinding light. The very air around you feels different, charged with an unfamiliar energy. Gone is the gentle warmth that we associate with a sunny day. The kind of warmth that makes you want to bask in the sun, enjoy a picnic, or take a leisurely walk. Instead, you're met with scorching heat, the air itself shimmering with intensity. The heat waves distort your vision, making the world appear as if it's melting. The ground would be too hot to touch, and the sun's rays would be unbearable even for a short time. Imagine trying to walk barefoot on such a surface. It would be impossible. This blue sun wouldn't just be hot, it would bombard Earth with intense radiation, especially ultraviolet rays. These rays would be far more potent than what we currently experience. These rays are invisible to our eyes but incredibly harmful. They penetrate the skin, causing immediate damage that we cannot see but can certainly feel. They damage DNA, causing mutations and increasing the risk of cancer. The very building blocks of life would be under constant assault, leading to a rise in health issues. Even brief exposure would be dangerous. People would have to seek shelter constantly, avoiding the sun's deadly rays as much as possible. The world would become a much harsher place. Landscapes that were once lush and green would turn barren and inhospitable. Deserts would expand, engulfing once fertile lands. The balance of ecosystems would be disrupted, leading to a cascade of environmental changes. The few remaining water sources would evaporate quickly under the relentless blue sun. Rivers and lakes would dry up, leaving behind cracked earth and parched landscapes. Life, if it could survive at all, would be forced to adapt or perish. Plants and animals would face extreme challenges, struggling to find the resources they need to live. The challenge wouldn't be just surviving the heat and radiation, but also finding food and water in this new, hostile environment. Humans would have to develop new ways to grow crops and find water. The very foundations of life would be shaken to their core. Our world, as we know it, would be transformed into a place of extreme survival, where only the most resilient could endure. Section 5. The photosynthesis puzzle. Plants under a blue sun. Plants, the basis of most life on Earth, rely on sunlight for photosynthesis. This process is fundamental to the survival of not just plants but almost all life forms on our planet. Through photosynthesis, plants convert sunlight into chemical energy, producing oxygen as a byproduct, which is essential for the respiration of most living organisms. But this process isn't as simple as soaking up any light. Plants have evolved over millions of years to harness the specific wavelengths of light that our yellow sun emits. The chlorophyll in plant cells is particularly adept at absorbing red and blue light, which are the most effective for photosynthesis. Plants have evolved to utilize the specific wavelengths of light emitted by our yellow sun. The chloroplasts within plant cells contain pigments like chlorophyll that are fine-tuned to absorb these wavelengths, making the process of photosynthesis highly efficient under our sun's light spectrum. A blue sun throws a wrench into this delicate process. The light spectrum of a blue sun would be vastly different, with an abundance of blue light and a significant reduction in red and yellow wavelengths. This shift would pose a serious challenge to the photosynthetic machinery of plants as we know them. The abundance of blue light and the lack of red and yellow wavelengths would disrupt photosynthesis as we know it. Plants that have evolved under our yellow sun might struggle to adapt to this new light environment. The chlorophyll in their cells would not be able to efficiently absorb the blue light, leading to a significant drop in their ability to produce energy. Some plants might wither and die, unable to adapt to this new light regime. The lack of suitable light for photosynthesis would cause these plants to experience stress, leading to a decline in their health and eventually their death. This would have a cascading effect on the ecosystems that depend on these plants for food and oxygen. However, nature is remarkably resilient. Throughout Earth's history, life has faced and overcome numerous challenges. Some plant species might possess the genetic diversity to adapt to the new light conditions. These resilient plants would be the pioneers in this new world, finding ways to survive and even thrive under the blue sun. Some plant species might possess the genetic diversity to adapt. Genetic variation within plant populations is a key factor in their ability to survive environmental changes. Through natural selection, plants with traits that allow them to better utilize blue light would become more prevalent, gradually leading to a population of plants that are well adapted to the blue sun. They might develop new pigments, capable of absorbing blue light and using it for photosynthesis. These new pigments would be a result of genetic mutations and natural selection, allowing plants to optimize their photosynthetic process under the altered light conditions. This adaptation would be a slow process taking many generations, but it would enable plants to continue playing their crucial role in the ecosystem. These adapted plants could become the foundation of a new food chain, supporting life in this altered world. As these plants thrive, they would provide the necessary energy and nutrients for herbivores, which in turn would support carnivores and other higher trophic levels. This new food chain would be a testament to the adaptability of life. The evolution of plant life under a blue sun would be a fascinating spectacle, a testament to life's ability to find a way, even in the most challenging circumstances. This process would highlight the incredible resilience and adaptability of life on Earth, showcasing the dynamic interplay between organisms and their environment.